So let's try and get the RPCs to sync on our replay as well. And the secret to that is we're actually going to get 2 network frames in this case. So okay, let's think. Yeah, let's go to our network frame, to our actual class for that. And we're going to make a new system.serial. I actually don't need to have this serializable, to be honest. Just so that we can see them in the inspector though, let's add them. So we will do system.serializable public class network frame RPC. Then this network frame will actually have a public float, a timer for when that network frame happened. And well, technically we should know what happened as well, but for now I'm just going to do a public vector tree. We're just going to treat it like you were shooting, which means you got a bullet, which means you shot the weapon. So that will be origin public vector 3 and position. So we'll get 2 network frame RPCs, 2 lists of network frames. Then each one of these guys will actually be responsible for handling a timer by themselves. Let's see, where's our network frames. Okay, so that will be public float. Doesn't really need to be public. We can just have a public float for network, or well, replay timer. I think we already have that, so we will say game timer. In update over here, we're going to just add on our game timer by time.delta time. So we're using this in 2 places, which means time.delta time will be used in this case, like this. And this will just keep counting until we reset our gameplay. Then inside the handler replay, we're going to be using 2 methods of this. So replay index return. So right now there is a little bit of yeah, we can assume that if the network frames are finished, you actually finish streaming. So we can assume that when the network frames are done, there's not going to be any RPCs afterwards. So let's see. With that in mind, we could be resetting, we could be playing on our game timer by time.delta time. We actually already have the timer. Let's see, we have the timer, replay timer. Okay, we're not doing any return. Okay. Well, then, if network frames RPC.count is greater than 0, let's start with that. Then network frames RPC 0.timer. If network timer is greater or equals to the game timer, then there's your frame, then remove that frame. Okay, so we have our network frame, so we just need to load it now, which means we could just go directly on the ballistics or well, we could just say controller dot, for now we can say controller dot shoot input equals true. Let's try this, and I'm just going to write debug log for shooting. Okay, then whenever we now need a method that will actually be creating a network frame in this case, so we're going to be doing public void add network frame RPC. And for right now I'm not going to be passing any data, I'm just going to be passing the game timer to this. When we reset our network frame, when we reset our replays, we're going to also reset network frames RPCs. We're also going to be resetting the game timer. Okay, so on ballistics, let's see, on ballistics, if we're sending this over the network, if we're not sending this over the network, we could say we kinda need the owner though. We kinda need the network print, which we can get from this. So this will be sent to the master. So that will be sent to everybody. So everybody is going to be playing, yes, which means we could just say player container add network frame RPC. Thing is, we need to know where the network frame ended and where it started, which means we could just pass. We only have origin and direction from this void. We would like to get back the hit point. Well, technically we could be saying vector 3. Down here we could be returning return hit dot point if there's any, or we could be saying hit position, so we get the value even if we don't return anything. So then back to the match manager, we could be doing it like this, and over here we could have vector 3 hit position as well. It's not ideal either because it kind of downplays the importance of this, but it can work. Alternatively, we could just do a reference variable to this and use that one. Okay, add network frame RPC. Okay, so after we create this, network frames RPC dot add f. Okay, let's test this out. I don't know how it will play, but let's see. Okay, it doesn't do anything. Why though? Okay, let's see when we are playing, when we're doing the replay. This didn't actually work either. Oh, when we're doing the replay, game timer. Well, let's just put a breakpoint when the replay is going to be happen. We'll see then what's going on. This might be a problem though, that the game timer is adding. So I'm just going to add it in here and in here. So they update at the same rate, give or take. Let's put a breakpoint, so that's this. Notice all of these are happening without even touching any network libraries, by the way, and that's on purpose because just testing all of this online will have been the biggest nightmare you can imagine. Trust me on that. Okay, so here we go. You have network frame timer. Game timer is at 8. Aha. That's... What? What just happened? The timer is greater than the game timer. Yeah, okay, it's not. Oops. That's actually the opposite. We want the opposite. We want the game timer to be greater than the network frame RPC, or greater or equals, because the network timer would just mean we passed it. Let's wait till this compiles. And now that I see this is flying off the ground, so probably fix that. Okay. Don't actually... We did get the bug. Didn't really... Now, okay, they all fire at the same time, I guess. I think that's just what that happened. They all fire at the same time. So let's maybe try, instead of changing the shoot input, instead of changing this even, let's say on the network print, let's force the controller current weapon, let's force a shoot over there. I'm not so sure what's going to happen with the game timer. Let's say game timer. Then are we adding on the game timer? We're not adding anything on the game timer. Then network print manager. Oops. Let's try this. We at least know we get the RPCs, we save those RPCs. The first one doesn't work. The first one is not actually a shoot, it's basically the projectile. It's the particle, not projectile. Okay, so yeah, I was correct on that. The game timer just goes haywire because you get your 4x35, 459. Like all of these keep firing, but the game timer almost starts from there. Oh yeah. We forgot to close the game timer. Oops. Silly mistake. Let's see. P.game timer should be set to 0. Damn it. Is play time, player dictionary. Yeah. So let's add a method for this inside our network print. Where we're going to say public void play, or well, start replay. So from here we just need these two, and this will be start replay. Perfect. Then on your network print, replay, and game timer, reset it to 0. I think that should do it. Let's test this. We didn't saw the direct, did we? We never saw this. And this never actually did any, didn't play any of the animation or any of the particles. So that's weird. Anyway, we'll see now. Maybe because we fired all of it together. I don't know. We'll see. Well, we did got some of the suits, but we didn't got all of them. Well, what? Well, that's kind of weird. I should have been getting all those hits. Oh, yes. One more thing we forgot. Or did we? Yeah, one thing is that we kind of have a slight problem with the network frame RPCs and the network frames. So if the network frames go higher than the replay frames, we know that we remove them, but we never remove the network frames RPCs. So that's kind of an issue. So we do know, however, how much game time is, and we do know how much replay frames are. So that means we could start deleting if game timer is greater than set amount of value. So if game timer is greater than replay frames, to find the replay frames we need to find the send rate. Okay, so here's the thing. Let's go on the game timer. Where do we have the game timer? Game timer, okay. I'm going to start with cleanup frames timer for the game timer. Okay, then to get that we need to calculate the send rate, where we need to calculate the replay frames for how many ones we're saving. That is an integer. That is, I think we're doing this every 1/10 of a second. So let's say if we use like 50 by 0.1, 5 seconds. Yeah, that should be that should be by send rate. Let's see what the send rate actual by send rate divider, which is send rate divider is of course 1 by send rate divider. So that's these are cleanups frame timer. Now if let's do another float next cleanup. So now when we are actually handling our, when we're doing a replay anyway, not when we're playing, when we're just recording, if game timer is greater than the next cleanup timer, if network frames RPCs.count is greater than 0, then delete remove at 0. Or better yet, maybe that's better. No, that will not delete. No, we have to delete up till this. Up till no game timer. Next cleanup. Yeah, okay. Here's what we're going to do. For network frames dot length dot network frames RPC dot count. Network frames RPC dot count -1. No, dot count. Network frames. Come on. Let's do network frame RPC f network frames RPCs I, then f dot if game timer, if f dot timer is less than, will always be less than. Hold on. So we add on the game timer, then we need to know that is your next cleanup. So each frame that is less than our next cleanup, we're going to be removing it. Which means since we are removing parts of the array, we need to be going the opposite way in the array. Like this. So network frames RPCs dot remove at I, or better yet, remove at f, because the index might change and will change. Okay, so f timer, next cleanout, next cleanout. Nah. Yes. So this needs to go next cleanup. Then on the next cleanup, then it's going to be game timer plus network plus cleanup frames timer. So that will be game timer plus 5 seconds. I think that's. I'm not so sure about this. We might need to brainstorm this offline when I'm not recording, I mean. So we'll try that later. If it doesn't work, we'll see what we can do, but I think it should be, technically it should be working. If we were recording the entire game like this, we should have no problems, but since we're not, we do have problems. No, it doesn't work. Don't know why it doesn't work though. We need to look. Well, first of all, we need to know that there's a cleanup happening. Cleanup. Okay. Removed. Let's write removed at plus f dot timer. Let's see how this will play out. Okay, so this one removed some. No. I think it just removes them. So that's not it. That's not how we should do it then. Game timer, game timer, game timer. Well, here's controversial thing. Cleanup frames timer. If game timer is higher than, no, we could be adding multiple times. We could be recycling the game timer as well. So game timer we call 0, and we could be saying network frames are, if network frames RPC dot count is greater than 0, network frames RPC dot remove at 0, and this needs to be network frames RPC dot count. And the next cleanup will be next cleanup won't be like that, will be cleanup frames timer. So games timer technically should be the same thing as the cleanup frames timer. I'm not entirely sure that this will happen, but only one way to find out. The stream would have been the easiest, to be honest, but that leads to its own problems, as we know. And well, he did fire something, but he's not firing everything. Let's put a breakpoint inside the handler replay for this one. Okay, here we are. So the game timer is at 4.2 and the frame timer is at this. Then I'm going to debug over here, put it down here. So this one now should be shooting. Should be shooting again 6.8. Yeah, that's definitely higher. But is he shooting? We did get the... I do see some values over here, but whatever, let's see. Well, we do get some shooting as well. That's weird. Yeah, I think we can find this. We could probably find this, but well, one solution will be to clean up. This will stay, but one solution will be to just clean up on each network frame. So the first network frame we are using, or inside the network frames we're using, we're also going to save the game timer. Okay, then network frames, load network frame, game timer equals f.gametimer. Then on the stream, f.gametimer equals game timer. That can work as well. Then we just need to clean up when we first play the replay. We just need to clean up till the point of the first frame game timer. Sure, why not? So this will be useless then. We're just going to be adding on a game timer. Then the first time we're going to tell us to play to the start replay, game timer will start by getting the first network frame, the actual first network frame, or well, let's see, float start timer, start with 0, then we're going to say if network frames dot count is greater than 0. Technically there should never be a case where network frames will be 0. So network frames 0 dot game timer will be your start timer. Okay, then well, actually we can just write this here right away on the game timer. Then for network frames RPCs dot count, if network frames RPCs I dot, well, we're actually going to have to go the opposite way, don't we? Yeah, as well, because we are moving network frames dot count -1 I greater or equals to 0 I minus. Okay, so if network frames dot see game or timer is lower than the game timer we have over here because it's the starting timer, then network frames RPC dot remove network frames RPCs I. So I think this will work because we're now going to be left with a new starting timer. We're basically rolling back on the frames we're playing, and we are removing every frame that is less than the starting game timer. Let's test this out. If it doesn't work, however, I'm going to pause the video. We're actually going to come back into this much later because, you know, it's not really that much important. It's just I wanted to cover this right now. Yep. Beautiful. That actually worked really great. So we have our frames, then let's add the correct positions then. Let's find it. Receive position rotation. Let's see. Start replay. Reset replay. Now, one thing that we need to know, however, is that the network play. Okay, yeah, he knows where to put it. Then we need to sync the hit position. Okay, then in here, add network frame RPC vector 3 hit position. Well, technically, we already know the origin as well. But, and here's a really nice but, why not pass the network frame instead, where you will only be updating the timer and add that there. Then instead of returning your hit position, that is the network frame RPC, and instead of returning you the hit position, we're going to be referencing a network frame, which is from the network print.network frame RPC. Okay, perfect. We're going to write this in a bit. And then we're going to be saying network print on network frame RPC frame equals new frame, and reference that in here. Okay, then add network frame, there's your frame, and reference that there. And then we can also go definition, and we can let's collapse all of that. We can set this to, we can initialize it as null. We cannot initialize it because it's a reference variable. Okay, so however, we can go down here and say we don't really need to return this position. We can just return void, and we can go down here and we can say if void if frame not equals null, then frame dot origin frame dot end position equals hit position, and frame dot that. Actually, here's another thing we can do. We know there is an impact ID, and we know that is, let's see, we only have one impact ID. Yeah, we are pretty much creating this, and we are creating, yeah, so we can store the impact ID as well on this case. So let's open up the frame for this public string impact ID. Okay, then frame dot impact ID equals impact ID. But here's another thing. We can just make a new public static replay bullet, where I'm going to be passing the network frame, network manager, network print actually, network frame RPC frame, and we're going to be avoiding doing the raycast. We already have the results of the raycast, so why doing it again? Okay, so impact ID, we get that from the frame dot impact ID. The transform point will be the frame dot end position. The look rotation will be frame dot end position minus frame dot origin. Is it? No, it will be the opposite, because we want to look towards the origin. Can delete that. Frame dot end position for the impact, for the bullet impact. Then we can get the bullet line, and the origin we can set this as the line start, so it actually points like the start. Yeah, so bullet line, bullet game object. Let's find the bullet game object. The bullet game object is here. Okay, bullet game object, then bullet line set positions, frame dot start or origin, frame dot end position, and I think that's it. We just need to open up the bullet game object then, and we now have a way to just cast a bullet and place any particles that played and actually place the bullet as well. So replay bullet, let's see what else do we need. I think that's all we need. The line start we have saved, impact ID, okay. Then on the network print, we could just say on the replay, you can shoot, but you can also go on the ballistics and say replay bullet and pass the network frame you have over there, and beautifully it will recreate that bullet. Okay, now I think on the controller we only just need to change one thing. We just need to pass null in this case, because you do not have oh, it's a reference. Oh. Whoops, it's a reference variable. I kinda don't want to use this, damn it. Well, you know what? We can just return this as a network frame RPC, I guess. I kind of don't want to create a network frame over here as well. Don't see the point of that. but if it's not referenced, okay, let's try without it being a referenced variable. I think because I think it's going to be a shallow copy. I think, not so sure. I guess we'll just have to see. I think it's just going to do a shallow copy, so it will still point onto this. So let's say, let's do debug.log frame.end position. At any position, this will return, and it's not at vector 3.0, then that means it's a shallow copy. It's not a deep copy. So it's exactly what we need. Let that compile. Then let's hit play and let's see what did we do. Yep, it's a shallow copy, perfect. So that means we can just go and kill this guy. Now that is pure beauty. Pure beauty indeed. So that's it. Let's see that we actually have the working replays properly with the bullets as well. Perfect. I'll upload myself, but it's going to make some noise on the microphone. So yeah, that's it. That's it for this part. As always, you know what to do. Like, subscribe, and if you like to see more stuff, more videos, more series, more of everything, then of course consider supporting my Patreon so we can keep making all of these nice things we're making. I'll see you next time.